Hello, everyone. Today, we're going to be talking about data harmonization and how is this being solved with Cloudin and OpenAI. In general, with all of the enterprise landscapes that I have seen so far, you always have this amount of diversity in your data. It could be coming from different systems which collect information about customers, product, and any other things, but also having the same purpose kind of systems like ERPs, which are built, which are having a multiple amount, sometimes according to our customers, up to 400 of those, which you have in your data landscape. And the reasons for this are the multiples. This could be because of the different business unit using ERP system for their own internal ways of doing the business and working. Then the other points within the same business unit, you might be having actually the departments defining their own working on ERP systems specialized for their own in different markets that they're having. Like a German market might not be the same, even though it's the same product, than the USA, both for different reasons. And also because, those times when this data got procured, it was the on-premise era usually. And what was additionally happening is that these on-prem systems usually weren't way much more cheaper to be separated and to be split around to serve each one of these departments rather than trying to make one giant, which would be ultra costly for no reason. And but however, now when you have these ERP systems, multiples of them, it will gonna be still the same enterprise, same business, same products that you're working on or product manufacturing or selling. And there might be actually there's just a very minor differences in regard to all of those, which is specific to the market. Like, I don't know, the labels of the product might be different in German written and the other one written in for US market and so on. But the majority of it is actually an overlap. However, even this overlapped information about products is something which turns to be also a challenge in itself, and that it is the information that people in each one of these departments have described the physical product that they're having described differently. And this is what we call the unharmonized data. For example, with one legacy system, you might be having this data where material types are predefined with a specific set of values that could be added. This is, of course, coded with this MAD, MAG, MAK, and there is a description somewhere in some table written, which defines what this code means. These little tables, which here is written check tables, it's called reference data, and you might be having this also information available. However, you might be having another system where, for example, the UK team is also having the same problem describing the physical product you're having. And they have also defined their own set of values, codes, that they are having for that material type on their own language and their own culture and their own ways that they could have been. And you can imagine having such a systems, multiples of them, everyone having different ways of describing the same thing. And at the end of the day, there were going to be a top level management. All of these years would be needing to provide a global report on just how good the sales are of the company altogether. Not in each of the countries, but all over globally. And this kind of issues like data aren't harmonized, being unharmonized, is the problem which will bring this report to be unreliable as well. And if the report itself is not reliable, you will gonna be having to deploy an army of the data engineers to fix this issue just for this reporting itself. You can imagine that will gonna drive a high cost because every single time you create a new report, that will gonna be done ad hoc. For this specific reporting, there are gonna be another set of I would say, data engineering wizardry, which will gonna be required to make this report properly. So nowadays, in the modern era, it's become more apparent for all of the companies to stop having this legacy systems available because you have now the cloud behind, which has unlimited resources. You can scale as much as you want. And that makes stop having a reason to have a multiple legacy system, but instead, let's build one single legacy system. And this is the beauty. You have one system used by all of the departments in all of the countries. However, they are all having their data in their own world, in their own culture, written differently. As we have seen with these material types, there's different values there and the different ways of describing it. Now, we need to harmonize this information into one single reference data or one single view of how material types are described. And this, according to one of our customers, would mean that you would, it's such a long effort, that's a large amount of effort required to do this, that for one legacy system, it takes one person who is actually an expert in that system, 1 full year to make it happen, to do this, all the conversions and everything. What could it suggest, and this is why what the challenges behind and why how long does it take, is the fact that it's just a lack if you would going to be having each one of the ERP systems exactly coming from the same vendor. You might be having different vendors, and each one of these vendors will be having different namings for the same thing, like a manufacturing date would be written in one place one way, another place another way, and you need to kind of merge it into one single attribute. As we have seen also in this case, in these 4 different legacy systems, the reference data, the ways how you see the material types, for example, is growing apart with the time. And it could be also within the same sub-departments as well, that they just simply use the system differently and they just don't communicate with the rest of the company. And at the end of the day, the biggest hurdle is how can we make decide on the standard values and apply it without really having too much of the efforts in this. So what Cluing here it enables you to do is you're going to sit in the middle and we're going to gather all of the information about both SAP data, master data, and that reference data, these views of the material types, and standardize these values and send the final results directly to this modern ERP system that you might be having. So how does this look like in Cluing? When we log into Cluing, you're going to be seeing that something that looks similar to this. And along with this, you're going to be seeing, for example, we have a certain amount of data that is being loaded. We're going to take a look at this data. And we have, for one side, certain lookup fields available. So if I look at one of them, we're going to be seeing, for example, these values here. And you can see that this is some other language. It is Serbia language. And what is very interesting, that, for example, I probably not being in Serbia for long, I don't remember anymore. How do you say aluminum can in Serbian in this more formal business point of view? The liminka itself, that is the word, is more slang approach. I don't know how you would say properly. And I put this like this. So it is just a description. It's not really even the official language, so it's a slang. So we have this information as well. So it makes it very realistic scenario as well. On the other side, we have also the other systems having exactly the similar data from different instances loaded. For example, in this case, is German, and in the end, it's also the English version. Each of these data has been loaded. But also we have the data loaded, which is come from SAP. Let's say if we look at one of the SAP systems, we're going to be seeing exactly this SAP-like information, where you have this kind of different values and different stuff, and as well as also the material type. And as long as for the material type, you'll see that this is different values specific to that system. Now, the question here and its issue here is that how can we merge these column names that you see above, which are very hard to understand, into a more human readable format in the place that you could actually understand, and you could also let business work with it, finish it, and also spend it out to the external modern ERP that we have been looking. For these purposes, we can use also something called Cluedin Copilot. And what it does is we deployed a large language model, which is running on your tenant. So that means that you don't have any data leakage. It's working with your data within your own environment, everything's safe. And then we taught him additional skills of Cluedin. So it's not only here about just you being able, like when you're bored with the Cluedin and mastering the data, you just chat about whatever, but you actually can give him commands and tell him, hey, I have this data. Can you help me out? Can you do this? Can you do that? And this is exactly the idea of Copilot. We have give him skills of many, among which also is the mapping of the datasets, and tell him, hey, map this dataset into a material vocabulary, which I have already created, and just try to find it yourself the best. So this is what we have done. Dataset has been successfully mapped, and he shows himself this mapping. As you see here, he did an amazing job. Material number is Material. For example, Stellungsdatum is the German shortening of the word created ad, and so on and so forth. There's a lot of here very well defined suggestions, and he kind of made this mapping, and this is your result. So now this is, it can be seen as an accelerator to make your data owner who does this migration from legacy system to this system to a modern ERP quicker, more efficient. And of course, you might not want or might not like what Claudine has, OpenAI has done this. And for these reasons, you will going to be using, you can always edit this and say, okay, I don't like one or I don't like another, and fix this. At the end, I also loaded a final data, which is a standardized type, new harmonized version of the data that I want this tool to be loaded. So this is my new version of material types, and I want all of the systems to comply to this new version. And I loaded this as well. So when we look at the data, and we can now search at what is all been loaded including, we can see we can look at two different views. First is having these views of the material types, and you see how many different types are there, depending, of course, of all of the systems that has been loaded. So there's like a 16 different values, and here you can see that this is all, you can already see that one way or another, PET, Plastica, a plastic, it's a plastic bottle, it's all the same kind of thing. So you expect this should be one value, there should not be so many of them. This is this issue that you're having about the harmonization. And the same can be seen if we take a view of the materials. Materials also having, for example, this type name here, which is completely different. That brings us to this other next point, is that now let's just simply stream this data out and make the report of how it is, like a before and after style, how it is looking before. So if I send this data using the export target to the local SQL server and send the materials, so this is a user interface, user-friendly way for you to stream the data out of the Cluedin and define exactly what you want to stream out. And this is the type name of the type of material. You're going to be having the report that looks something like this. And you see this report really looks very colorful, but it is exactly showing what we have had. The distribution of values does not really give you a reliable report. How many different material types from all of these systems do we have actually? Because there is a glass here, there's a glass here, and there's a stack log here. That is the three different words for the glass in different languages. So now, when we look at this material types, how is this being solved? So one of the major things that we used to solve this is, again, OpenAI. And we use this to create a rule where the action is for, we run a little prompt of the OpenAI on every single record, on a watch record, every single material type that we have seen. And this looks something like this. Given the following table, this is the standardized values that we have. Find the closest match to the ones that you have in this record, the description that you have in this record. So we let OpenAI decide on his own if this is good. And also along with this, we ask him to provide his confidence and the explanation tells us. So I have already created this rule. We have exactly said, hey, run on all of these material types. And this is the action that we want to do. Exactly the same text that I have shown. So when this is being run on every single record, we're going to activate the rule and we're going to run this. You're going to be seeing this rule apply to all of these material types. So in a moment, we're going to be seeing its results. So we're going to go in and just simply take this view again of the material types. So now you see that there's a much more information about each one of these records. First, you see these old values, that's MT4 and PET. He realized, okay, accidentally it's also MT4 in the standardized column, but for PET is for him, that means because it's a plastic. So, and PET is very difficult word for any other language to be figured out. And he knows PET is this specific word here, and he explains you here why he did it. Let's just look back to this slang Serbian word for the aluminum can, limenka. Limenka, it's also saying how many, it is most likely the aluminum can, as limenka is a common term for a can in some Slavic languages. So he already knows this even slang of Serbian, and Serbian is not really so commonly used and written in the internet. He knows it very well that it's a slang, and he connected it to the right type. So now we have for each one of these material types specific standard code. So now the question is, we still have, this is the reference data. This is the reference data connected to those materials that we have. It's still not standardized. So what can we do next? As a next point is that what we can do is we can use something called the duplication project. It's a very, very powerful tool which enables you to create a specific matching rules, and those could be both fuzzy rules or exact rules, but it gives you this capability to easily create rules, get the results, see if this makes sense, and find duplicates this way. It can be done over and over again until you find something interesting. Right now, for this particular purpose, we want to find exact matching codes for the this AI delivered standard codes. And along with this, of course, you can use these normalization techniques, which gives you this capability of before the matching itself, let's fix the data. Let's put them all in a lowercase. Let's remove all the spaces and everything, and then try to do the matching. So now, if we generate matches, we're going to be getting these results here shown up. As you see, we have now 4, exactly what we have seen on the slides. This is what we expect, 4 different values. And when we click on one of them, just for the sake of our sanity, we get to see side-by-side comparison of 4 different material types from different systems, which we want to, which he thinks that it should be merged. And we take a look at them and we see it makes sense. I mean, there is the aludose, aluminum can, and limenka. It is all in all the languages correct. So we can either pick up each one of them ourselves, or let Gludin decide on his own what he should pick up. This automatic approach will gonna be used on the most actual record, but you can change this behavior if you want. So now that we have this one approved, this approval process is just for this showing you that this could be done. But because we are so certain, so sure of these all values, we can also just simply approve all automatically. All of these things can be automated. And we can merge all of these records as well. At the moment we merge these records, there will be a couple of very amazing things that will be happening. First things first is that we have now all of this data load. So let's take a look at first our material type. For example, if I take a look at this data, material types, now we have only 4 of them. And take a look at them. You have all of them written here, MT1, 2, 3, 4, their confidence and the codes. So now we can look at one of them, for example, and we can then simply just we can just simply take a look at one of the records, and not just that we have had this standardized code now written, but we have also information about all the past values from all the previous systems, system 1, 2, and 3. What it gives us the capability is that we were going to be this way, be able to use these material types that we've now merged and connected together into a one material type table, mapping table, which we can export out and use for the mapping of any other system anywhere else, because we have this stored here and documented here. On top of that, we could also take a look at our materials and see just how does this change. As you have seen, we have merged all of these lookup tables together, all the values into one specific values and unify these values. And you see here, this has automatically been modified. If you remember at the beginning of this video, we have had here all differentiated heterogeneous information, each one from their own system. Now we have already done this and it's all working. So now the question is happening, but how does this all look like? Because we have now updated this information about each one of the materials. How does our report in the end looks like? And you see, Cludin keeps a track of everything that is happening within Cludin, and any changes that happens will trigger an event and update the report or tables outside. And you see here, there was not anymore all of these different types of the material types that we had from original system. We have now a harmonized version of the data that we have according to our standardized code. This is enormous amount of time saved that your data domain experts could focus only on like anomalies and just finish this much earlier than just that 1 year that we mentioned originally. And this kind of tools can be used for any other point of view. Together with Cludin, you could look at your master data, information about customers, vendors, suppliers, also in terms of anomalies, trying to find what kind of information it makes no sense, or enrich the information if or find validation of policies. If one of the policies could be very hard to do is if the companies that you're working with is within European Union, or even worse, if it is within the inside of the US sanction list, so that you should take care that it's not proper, or picking up the ESG scores and see if this is a good ESG score that you should work with and as a company. There's many additional things that you can use OpenAI for to provide this additional intelligence into your master data. Thank you very much for your time.